These are the notes for section 2.2 part 1. You should have a handout that goes with these that you either got in class or I will post a link to it along with this on the website. So today for section 2.2 we are talking about a lot of new vocab. We're talking about functions, domain, and range. Those are the three things we're going to talk about today. So a function is our first vocab word, and a function is a special kind of correspondence between two sets. So we learned how to write things in set notation. A function takes two sets and it tells us a correspondence between them. Usually we have kind of thought of these as equations, like y equals 2x plus 1. That's a function. It tells me that you take a set of x and you assign it to a set of y, and you do certain things to it to get from one to the other. So for now we're going to define domain and range kind of simply. For now, we're going to refer to the domain, we're going to think of it as the input, and we're going to think of the range as the output. So, for example, I know you don't have a lot of room around here, but if you have some room to draw, you can kind of think of your function as sort of like a machine. Kind of like, you know, like at Subway, they take your sandwich and make it, and then they put it in the heater, and then it comes out later. It's like kind of like a function. The oven is kind of like a function. So you take your input, you put it into a function, and it assigns an output to it. So for example, let's say our function was y equals x plus 1, or remember we can refer to functions as f of x equals x plus 1. This just means a function called f, and our input is x. And what we're going to do to that x is we're going to add 1 to it. That's what that function means. Sorry, that kind of looks bad. F of x equals x plus 1. Let me rewrite that. F of x equals x plus 1. So for example, if we put in, let's say, a 3, we'd put a 3 into that equation, and then it would come out 3 plus 1, and it would come out a 4. That's kind of how you can kind of think of a function. It has an input and an output. So when it comes to domain and range, the domain is the input. So for example, these are some examples of functions that assign one set to another. So for example, each person in a class can be assigned a date of birth. A barcode in a store, each barcode in, Target or something, it corresponds to a price. And each real number has a cube, the power of 3. So those are all examples of functions. The first thing, what you're kind of putting in, that's your domain. That's your input. And the thing that comes out is your range. That's your output. Domain and range. Domain is input, range is output. So in order for something to be a function, because a function is a special kind of correspondence between two sets, the correspondence between the two sets has to assign each member of the domain to one member of the range. That's what's important about a function. In a function, each member of the domain corresponds with one and only one member of the range. So a domain cannot get more than one value in the range. That's what's important. A domain only gets one arrow going from it. A domain cannot go to two members of the range. So for example here, we're going to determine whether each of these correspondences is a function. This first one, each member of the domain corresponds with exactly one member of the range. 1 goes to 107.40, 2 goes to 34.10, 3 goes to 29.60, 4 goes to 19.60. So yes, this is a function. Each member of the domain corresponds with one member of the range. On part B, there's something a little weird here going on. We've got two members of the domain. They're sharing one member of the range. So remember, our definition of a function is that each member in the domain gets just one member in the range. Well, this is still true here. The 5 in the domain is corresponding to one member of the range, not more than one. And the 6 in the domain only gets one member of the range. So yes, this is also a function, even though two members of the domain are sharing a range. That's okay. We just can't have one domain member corresponding to more than one of the range values. So here we've got a domain and range again. We're going to decide whether this is a function. So we've got Chicago is in the domain. It has two baseball teams, the Cubs and the White Sox. That means this is automatically not a function. What made this not a function is that one member of the domain, Chicago, it got two members of the range. That is not okay for something to be a function. So that is not a function. Now, if we switch this and look at it differently, if we think of the baseball teams as the domain and the cities as the range, this is a function because there's no member of the domain that has more than one member of the range. So yes, this is a function. So the only time something is not a function is when you have a member of the domain with more than one arrow coming from it, like that. That's the only time something is not a function. Now we're going to take some short word problems and decide whether they are functions. It says, assume that the item mentioned first is the domain of the correspondence. Part A says, the correspondence that assigns a person to his or her weight. So what you want to ask yourself now is, can a person, that's the domain, can they get more than one weight? Can you say, well, I weigh 100 pounds and I weigh 150 pounds? No, you can't have more than one weight. That's silly. So this one is a function. Okay, I'm going to say yes, because a person cannot have more than one weight. So this is a function. Yes, it is a function. It assigns each member of the domain to only one member of the range. Part B says the correspondence that assigns the numbers -2, 0, 1, and 2 to each number square. Let's write this out like we saw those other ones, the domain and our range. So our domain is the input, -2, 0, 1, 2. The range, it says it's each number square. So we're going to square each of those numbers in our domain. So -2 squared, that means -2 times -2. That's +4. 0 squared, so 0 times 0, that's 0. 1 squared, that's 1 times 1, that's 1. And 2 squared is 4, so it's going to go to that range. Now you want to ask yourself, are there any members of this domain that have two arrows coming from them, that have more than one square? And the answer is no. When you square a number, there's only one answer you can get. So in this case, this is a function because each member of the domain is only assigned to one member of the range. A number cannot have more than one square, so it is a domain. Last part C, it says a best-selling author the correspondence, I should have wrote, the correspondence that assigns a best-selling author to the titles of books written by that author. So you want to think, are there any authors, or could a best-selling author have more than one book written by that author? Well, if they're best-selling, I kind of hope so. So for example, if we take J.K. Rowling, we could assign her, a best-selling author, to multiple titles of books. You could assign her to Harry Potter and the Sorcerer's Stone. I think I spelled sorcerers. Yeah, I've spelled that wrong. Oh well. And you could assign her to Harry Potter and the Goblet of Fire. And you could keep going on and on and on. Goblet of Fire. So you can have an author, a best-selling author, have more than one book assigned to them. So the answer is no. This is not a function because each member of the domain does not have only one member of the range. A member of the domain can have more than one member of the range. All right, so we're going to do another example with domain and range. So points can form a function or a correspondence. So here's a list of points here. -6, 7, 1, 4, -3, 4, and 4, -5. So just a set of points can also show a function. So the way it shows a function is that each x value is assigned to a y value. So whenever you're talking about points or an equation, your x values are the domain. That's the input. So I put this little thing here. This always helps me remember domain and range. Dix-Roy. You can remember this. I would write this. You could write maybe right below it would be a good place to fit it. So you can remember that the domain is tied to the input, which is the x values. So it's DIX, domain input x values, while the range refers to the output, which are y values. So Dix-Roy helps you remember that domain is the input, which are the x values, and the range is the output of a function, which are the y values. So if you were writing down the domain or range of a function, like an equation or points, for the domain, you're going to list anything that x can equal. Okay, so when it asks for domain, it asks for what can x be? Well, if I have a list of points, there's only a few things x could be. X in this case could be -6, could be 1, could be -3, or it could be 4. Now, since we just have a list here, let's write these in roster notation. We want to make sure and write them from least to greatest. So -6, -3, 1, and 4. Those are anything that x can equal in that correspondence. Now let's write the range. The range is the y values. So we've got some y values here, 7, 4, 4, and -5. So we're going to write the range. Now remember, we're writing a list of what it could be, so we don't have to list 4 twice. We can just say, well, y could be -5, 4, or 7. Okay, we don't want to list it twice. That's redundant and unnecessary. We only need to list 4 once because we're just saying, hey, 4 could be a y value. It's in the range. It's included in there. So Dix-Roy, domain, it goes with the input, which are the x values. Range is the output, which are the y values. All right, so we're going to start looking at some graphs now and finding the domain and range of those. So we're going to look at this function over here to the right. It's called f. For the function f, determine the following. And I want to point out that this is a lowercase f. That's really important. We pretty much always use lowercase letters for functions. You could see an uppercase one sometimes, but it's really important to use the right case, either uppercase or lowercase, because you could have a lowercase f and an uppercase f in the same problem. So make sure you use the correct case when you're writing letters in math. So on A it says, I want you to find the member of the range that is paired with -1. Now remember that range refers to y values. So we're trying to find the member of the y values that is paired with -1, which must be in the x values, because the range is y, so we're looking for what's paired with -1, which will be our x. So what I'm going to do to find this is we're going to go to -1 on our x-axis. It's right here. We need to find what is the y value of the function when x is -1. Well, the y value of the function right there is -2. So the member of the range that is paired with -1 is -2. I'm going to skip to letter C really quickly because it's very similar. So this one says the member of the domain that is paired with -4. So domain is an x value. We're looking for what's the x value that's paired with -4, so -4 must be the y value. So what we want to do is find -4 on our y-axis. We go over until we meet our function. And we can see that x is -2 here. Now, you might be thinking that that's kind of tricky because look, if we go on the other side over here, there's another value of the domain that pairs with -4. Okay, when y is -4, x could either be -2, or in another place on the graph, x is +1. So we want to include both of those there. Now let's go on to writing the domain and the range of this function. So for the domain of this function, you want to remember that we're looking for, domain is the x values. So we're looking for what can x be on this graph. And since x is this direction, that's the way x goes, we're going to look left to right. How far does this graph go left to right? So maybe one kind of useful way of thinking about this, and you don't have to think about it this way, is if you had like a big rectangle. Okay, I'm going to make 2 of those here. Okay, we want to move them until we're covering up what this graph can be from left to right. So I'm going to move to this graph coming from the left, and I'm going to stop as soon as I hit it. So there's where I hit it, right there. Now we want to see how far does the right does this graph go. So I keep going, that black line is still going, the black curve is still going, black curve is still going, black curve is still going. Oh, it stopped. So right there. So my domain ranged from right here, which is -3, but it does not include -3 because it's an open circle right there, all the way over to over here at +1, and it includes +1, I believe, because it's a closed circle right down here. So our domain ranges from -3 to +1. So the way we can write this is we start at -3. Our x has to be greater than -3, and it has to be less than or equal to 1. This is the way of showing that it ranges from -3 up to 1. It does not include -3 because you can see that open circle on the -3 on your graph. If you wanted to write this in interval notation, you could write it like this, -3 up to 1. But I want you to know that for a solution, I expect you to write it this way, and that's how the book is going to show your answers. So unless I ask you to write it in interval notation, write your solution with inequality symbols, please. Now we're going to look for the range of that function f. So I'm going to erase some stuff over here to make this a little easier to read. Now remember, when we're looking for the range, we're looking for the y values. So we're asking ourselves, what are all the values of y that are shown on this graph? So remember, y is an up and down direction. We're looking for how high and low does this graph go when we're looking for the range. So I'm going to use these rectangles. I'm going to move them this way. You could even use like 2 little pieces of paper if this helps you. Okay, I'm going to see how high up this graph goes. It looks like this is the highest point on that graph right here. I'm going to try to make this a little bigger. I don't think I can. So that's the highest it can go, and the lowest it can go, if I keep going up until I hit the graph, is right there. I guess I can't make, I'm trying to make this one bigger, but I don't think I can. So it goes right there, but pretend this rectangle is a little longer. So my range of this graph ranges from, at the lowest, let's see, at the lowest this graph is at -4 on the y-axis, and it hits it. That's a closed circle right there. It also hits it right there. The highest it goes until I get to that other rectangle is right here, where my y value is 0. Now you might think it doesn't hit 0 because there's an open circle right there, but it does hit 0 right there. There's no circle, but the graph still hits it. So it goes from -4 all the way up to 0. So our range is from -4, it hits -4, and it's all the way up to 0, which it also hits. So x is greater than or equal to -4 and less than or equal to 0. Oops, I made a mistake. Since range is y values, we want to mark it with a y. That is what my y ranges from in that graph. The lowest is -4, the highest is 0. All right, we've got one more example here of a different kind of graph. So this is called a parabola. It says for the function g represented below, determine the domain and the range. So remember, domain is my left-right movement. It's how far does my graph go to the left, how far does my graph go to the right. This is an interesting graph. See these arrows on the end? That means this graph, if you wanted to draw it, it would go like this forever and ever and ever and ever and ever and ever. So if you think about left to right, there's nowhere we can really stop this graph. Okay? It's going to keep going blah, 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 blah to the left and on and on and on and on to the right. Forever and ever and ever. It's going to keep getting bigger and bigger. So my domain is all real numbers. This domain is going to keep going and going and going forever and ever and ever. Now my range, I think there is a limit we can put on this. So remember, range is my y, or my up and down movement. How far up and down does this graph go? Well, there is a lowest point on this graph, right? Right here is the lowest point if you're looking up to down on this graph. So it hits at a y value of -1. So I know I'm going to go from -1 up to up, forever and ever, right? There's no place where we're going to put a limit on this going up. So all I need to say is that my y, the range, the y, is greater than or equal to -1. We don't need to say it's less than infinity because it doesn't really make sense. It's just bigger than -1. Any y value greater than -1 is going to be shown on this graph somewhere. That's the range. All right, so please bring this to class with you. We'll go over it, and then we'll do some practice problems.